All right, now we're doing multiplication as scaling. Without multiplying, circle the problem in each set with the greatest product and underline the problem with the least product. Solve the problem any way you choose. So let's think about what we're doing here. So in set A, we have half of a group of two. So if there's two things and we want half of them, what are we going to get? We'll get a 1. 3 over 3 times 2. 3 over 3 equals 1. So 1 times 2 equals 2. Remember, 3 over 3 equals 1. So that's like a whole number by a whole number. And 4 over 4 times 5 sixes would be like saying 1 times 5 sixes equals 5 sixes. So back to our directions, we want to circle the problem with the greatest product. So the problem with the greatest product, the biggest number, is B. And the problem with the smallest number is C in that one. Now let's take a look at set 2. So if we want to do some estimating, we know that this is kind of like saying 4 times 2.5 or 3. So that number is going to be between 8 and 12. For B, 3/4 of 2.5. And for C, 4/4 of 2.5. So we know 4/4 equals 1. So that one's going to equal 2.5. 3/4 of 2.5. 3/4 of 2.5 is 3/4 is less than 1. So my answer is going to be less than. My answer is going to be less than. Whoops. My answer is going to be less than 2.5. Oh, that's a mess. And then, so for that one, the biggest number is going to be A, and the smallest number will be B. And for set C, let's go through and see what we have there. 3/4 times 6 is like 3/4 times 1. So that is 3/4. 3/4 times 1 and 5 sixes. 3/4 is less than 1. So our answer is going to be, our answer will be less than 1 and 5 sixes. And then for C, we have 1 times 5 sixes is going to be 5 sixes. So we can say, for that one's a little trickier. Things are looking a little close for me there. So 3/4 and 5 sixes. I'd say 3/4 is smaller than 5 sixes. So I'm going to say this guy's smaller. And the biggest number is going to probably be B on there if I use some math reasoning skills. So how is 3 over 2, 3 over 3 times 2 the same as saying 1 times 2? Well, 3 over 3 equals 1. 6 over 6 equals 1. 7 over 7 equals 1. 101 over 101, they all equal 1. That's another way of showing 1. And we know that because when we do subtraction of fractions and we borrow, we bring over fractions that look like that with the numerator and the denominator is the same number. Okay, how can you use number sense to evaluate the size of a product? So this is when you're using your thinking strategies here. So Sue knitted scarves that are 4 feet long for herself and her friends Joe and Alan. After a month, they compared the length of their scarves. Some scarves had stretched and some had shrunk. The results are shown in the chart. How had the lengths of Joe and Alan's scarves changed? So Sue's was 4 feet to begin with, and it's 4 feet. So there was no change for Sue's. So Joe's was 1.5 times 4. So Joe's was a stretch. His got longer. Because I know 1.5 times 4 is going to be greater than 4. Because 1 times 4 is 4. So I'm going to add, I have more than that. 3/4 times 4, this one did a little shrink there. So that one shrunk because 3/4 is less than 1. So I know that 3/4 times 4 is going to be less than 1, and 1.5 times 4 is going to be greater than 1. And you can see on the number line, a little bit illustrated on the number line too. So let's see what we're doing here. So why does multiplying a number by 3.5 increase its value? Well, when you're multiplying any number by 3, 3 is greater than 1, 3.5 is larger than 1, so it's going to increase your value. Triple it by 3.5 times. Does the scaling factor always have to be the first factor in an expression? No. So we could have said the scarf was 4 feet and it's 1.5 times bigger, or it was 1.5 times bigger and it was 4 feet. Either way, because we can use, remember we have the commutative property, right from the first chapter. Commutative property applies to addition and multiplication. We can change the position of the numbers, and we're still going to wind up with the same value. So that's a no. For number 3, 4, and 5, we're going to use greater than, less than, or equal to. So let's take a look what we have. And you do not have to solve these. You're just using your math reasoning skills. So we know 3 times 2, the whole number 3 times the whole number 2, if I was going to use the distribution properties to solve this, which is making one of those, you can do it in the box, or you can say 3 times 2 plus 3 times 2/3 plus 1/2 times 2 plus 1/2 times 2/3, and so on. We know it's going to be bigger than 2 2/3 because just right here, 3 times 2 is 6. So we know that's going to be greater than. For the next one, 4/5 times 2 2/3. We know 4/5 is less than 1. So when we multiply a number less than 1 times 2 2/3, we're going to get a value smaller than 2 2/3. And for number 5, 4 3/5 times 4/4, which equals 1, is going to get a value equal to 4 3/5. So in this lesson, you're using number sense and greater than, less than, or equal to try to figure out the values. And remember, whenever you see a numerator and denominator that are the same, like 5/5, that's a 1. 5/5, that's a 1. Don't forget that. 2/2, that's a 1. So multiplying any number times itself is going to get the number that you started out with. All right, there's scaling for you.